Okay, so good evening. Presentation, can I start? So I'm Lior Bar Shalom, co-founder and CEO of Arbel Energy, and with me, Matan Arbel, co-founder and CTO. When it's come to the space application, the sun provides the best energy source. Let us show you how Arbel Energy is utilizing this potential in innovative ways. Solar solutions today have many challenges, especially in the space environment. Most technology like silicon solar cell are heavy, bulky, and only convert around 20% of the sunlight into energy. Advanced options such as a tandem or multi-junction technologies offer high efficiency. However, these solutions are complex to manufacture, heavy, costly, and lack scalability. Often they become a bottleneck and can delay space projects. At Arbel Energy, we are developing a unique solar technology, a lightweight, flexible film that works like a sticker or a solar wallpaper. It can turn any surface into a source of clean energy, depending on the application. And 1 kilogram can produce 2 kilowatts. And what makes us stand out is our innovative production method, which is the both simple and cost-effective. So how are we doing that? Please, Matan.
As Lior said, basically most current technologies are what's called single junctions, which are single material that reacts to a single wavelength. These technologies are actually very limited. And their physical attribute, physical limit is about 30%. They're also, most of the energy they absorb, they actually convert into heat. So the next step, just like Lior said, are tandems or multi-junctions. Now they're basically solar cells that you basically stack a few materials together. You get, each material has a different wavelength response, and then you get less heat wastage, more conversion. These are very efficient technologies. However, they're very costly. Now, their physical limit is actually very good. It's between 45 and 60%, depending on how many junctions, which materials, etc. But they're very complex to manufacture. So their high manufacturing is actually, their yields are very low. So even if you're willing to pay a lot of money to get them, you can't make as many as you'd like. So the next evolution of the technology is actually if you can take these advantages and squeeze it into a single junction or a single structure. At Arbel Energy, we use nanocrystal quantum dots, which are very interesting materials that you can control their band gap or their wavelength responsivity through their sizes. So through a very special structure, we can actually make a very, very efficient solar cell. Now, for these nanocrystal quantum dots, they have a very interesting attribute that they don't convert the energy into heat, but rather excite more electrons. So under the same illumination and the same photons, we can actually make more current. So if to summarize, nanocrystals, we can control their band gap and we can make really efficient structures for solar cells. They actually make a lot more current because of that multi-exciton generation response. They're very cheap to synthesize and to fabricate from. What you do is you basically, you make inks out of them. You get them as powder, you make inks out of them so that you can coat whatever substrate you want. So for example, for space applications, if you take a mylar cell, which is a very, very thin cell, and you just coat our technology on it, you can actually make an extremely lightweight solar sail, unintended. So that makes it extremely relevant for space applications. So our technology is actually was thoroughly tested in TNO by their Soliance Institute, which is a leading research institute for solar innovation. We've successfully created a prototype with scalable manufacturing methods that proves that our technology can take out of the lab and into mass production in record times. We also hold granted patents in key markets, which gives us a competitive advantage.
And this is what a global exporter recognizes about Arbel Energy breakthrough. Well, our journey is ongoing, but we have already received validation from our research institute and key players in the solar innovation fields. We're still in the development phase, but quantum dots have already shown a promised potential for the space application. Our next steps are to collaborate with the design partners and advanced testing adopt our technology for the space market. So imagine urban energy technology embedded in this solar cell, a lightweight, efficient solution that unfolds in space, delivering clean energy for the next generation of satellite and mission. Thank you very much, everyone.